Welcome. Today you will learn about Clever Hans, the horse that seemed to solve math problems, and what it teaches you about unintentional cues, experiment design, and avoiding false conclusions. In this session, we will first recap bias and expectation in research. Then we'll take a look at the famous case of Clever Hans as a striking example. Finally, we discuss what we can learn from this story for designing better experiments. When running experiments, it's essential to control for all potential causal factors. Otherwise, you can't be sure what's really driving the results. One important risk is experimenter bias, where the researcher's own expectation unintentionally influence the outcome. The story of Clever Hans is a classic example that will remind you to carefully control and use objective methods, as your own expectations can actually create patterns and causes that aren't really there. Hans was a horse owned by Wilhelm von Osten, a German mathematics teacher who claimed to have taught Hans an astonishing range of skills: adding, subtracting, multiplying, dividing, working with fractions, telling time, tracking the calendar, distinguishing musical tones, and even reading, spelling, and understanding German. However, you will see the real story behind his abilities reveals more about humans' expectations and subtle cues than about mathematically gifted horse. On stage, Wilhelm von Osten would pose questions to Clever Hans such as, if the 8th day of the month comes on a Tuesday, what is the date of the following Friday? Hans would then tap his hoof to signal the answer. The questions could be delivered orally or even shown in written form, which made the act seem all the more impressive. Von Osten toured with Hans throughout Germany, performing for crowds and experts alike, and notably, he never charged admission. For many, this seemed to prove the authenticity of Hans' abilities, making his eventual unmasking all the more surprising. In response to growing public interest, the German Board of Education appointed a commission to investigate Wilhelm von Osten's extraordinary claims. Philosopher and psychologist Carl Stumpf assembled what became known as the Hans Commission, a panel of 13 people, including a veterinarian, a circus manager, a cavalry officer, several school teachers, and the director of the Berlin Zoo. In September 1904, they concluded that Hans was not using any tricks. The investigation was then passed to Oskar Pfungst, who dug deeper. He designed controlled tests, isolating horse and questioner from spectators, using different questioners, applying blinders to limit Hans' view, and varying whether the questioner even knew the answer. Pfungst also tested the ideas himself, playing the role of the horse while volunteers asked him questions. Remarkably, in 90% of cases, people gave away subtle cues, shifts in posture, changes in facial expression, that revealed the correct answer. As the horse taps approached the right number, the questioner's tension visibly increased, only to relax when the final tap landed. Hans had simply learned to read those cues, not the calendar or arithmetic. As a side note, similarly, AI systems today don't truly understand language, images, or concepts in the human sense. Instead, they pick up patterns, correlations, and cues in their training data, which mimics understanding and simulates intelligence. For their applications, this is mostly good enough. Pfungst's experiments delivered a clear verdict. Hans could still answer correctly with someone other than von Osten asked the questions, so fraud was not the issue. But there was a catch. Hans only succeeded when the questioner knew the answer and the horse could see them. This meant Hans wasn't solving problems, he was reading subtle, unconscious cues in human posture and facial expression. This concludes the Clever Hans effect. The social communication systems of horses probably depend on the detection of small postural changes, and this may be why Hans so easily picked up on the cues given by von Osten, who seemed to have been entirely unaware that he was providing such cues. The capacity to detect such cues is not confined to horses. Fangst made an extremely significant observation. After he had become adept at giving Hans performances himself and fully aware of the subtle cues which made them possible, he discovered that he would produce these cues involuntarily, regardless of whether he wished to exhibit or suppress them. Recognition of this striking phenomenon has had a large effect on experimental design and methodology for all experiments whatsoever, involving sentient subjects, including humans. The clever Hans effect occurs when an animal or person appears to perform a complex task, but is actually responding to subtle, unintentional cues from humans rather than demonstrating true understanding or skill. It highlights how expectations and unconscious signals can influence behavior and experimental outcomes. The clever Hans effect has important implications across research and AI. Double-blind studies. It highlights the need to prevent experiment bias. If researchers unconsciously signal desired outcomes, participants or even animals may respond accordingly. Double-blind designs where neither the experimenter nor the subject knows the key conditions help eliminate the influence. Reactivity. The effect demonstrates how subjects' behavior can change simply because they're being observed or because the observer's expectations are subtly conveyed. This can distort experimental results if not carefully controlled. AI and machine learning. AI systems can pick up on intended patterns in data similar to Hans responded to cues. For example, a model might learn to classify images based on background artifacts instead of meaningful content. Awareness of the clever Hans effect encourages careful validation, rigorous testing, and transparency in training data to ensure models learn the intended signals rather than the spurious correlations. In short, the effect is a cautionary tale about the hidden influences, whether human or computational, that can mislead conclusions. So, the key takeaways are: apparent skill may result from subtle, unintentional cues and not true understanding. For experiment design, measures have to be taken to avoid the clever Hans effect, for example, double-blind studies. In AI, models may learn spurious patterns instead of intended signals. But for most applications, this is still good enough.